noticed that the video that I made yesterday, which I'm making them both this morning while you guys are sleeping in and having a snow day, I came into work to make some videos. The audio was really bad, so I'm going to hold my microphone in hopes that the audio is a little bit better. We're going to be finishing 11.2, which is again on exponential growth and decay, but this time we're going to use exponential growth and decay to model real world problems. And if you remember back to Algebra 2 et al., I know that they did this because I was helping some kids study for their finals, and they were doing this exact same thing. So hopefully this will be a bit of a reminder. I'm going to start out with a word problem. So a car depreciates at a rate of 20% per year, and if the car originally cost $20,000, the depreciation can be modeled like this. So depreciation just means that the car loses money. Or value, really, I should say. It doesn't lose money, but it loses value. So part A says find the value after 2 years. So hopefully something that you would do while you're taking notes is to pause the video and try to find the answer before me. I do have the answers written down in my notebook. So the value after 2 years, this means that time is going to equal 2. So I'm going to plug this in. And then you're going to type this in your calculator. I would make sure you type in this part, the 0.8 to the x first. And then when you're done with that, multiply it by 2,000. But I got, and hopefully you got the same thing, 12,800. B was to graph it. I don't have a lot of room. But as we talked about on the first day, this is where it starts. And this is how it changes. So I know that if I make a quick sketch of the graph, that it crosses up here at 20,000. And it is getting smaller and smaller and smaller. I'll change my color here. So this is a decay problem. And my car will never reach $0. Now, that might be unrealistic because at some point it's not worth any value to anybody. Maybe some value for parts. But at some point a car probably does hold no value. But realistically, or on this graph at least, it's never going to reach 0. Okay, it would always maybe be worth some pennies to somebody. But, like your car is totaled, it's worth nothing to you anymore. So I know that it's decay because this number here, this 0.8 is that number B. It's between 0 and 1. It is a decimal. And so I know that it's decay. And then part C says, where does the 0.8 come from? Well, it comes from the fact that we have 100%. So I'm going to use 1 as 100%. And then I lose 20% every year. So it comes from the fact that I am keeping 80%. So part C means every year I keep 80% of my value. So instead of saying losing 20%, I'm going to change it around to say I am keeping 80% of my value. So I'm going to move on to those formulas that hopefully that you remember way back from Algebra 2. And if you don't, it'll kind of be like a reminder to you. So talking kind of about exponential growth and decay. Your book uses this one once. It's in one of your problems. I don't really love this one, but since your book uses it, I'm going to make sure that we talk about what the pieces always mean. T always means time, which is good, right? Because that's a consistent for us. T always means time. R always means rate. P always means the principal, not principal like Mr. Helke, but principal value, which means the starting point. So if your grandma gives you some money, maybe she gives you like $500, you're going to put it in an account and earn some interest on it. $500 is your principal, kind of where you start. This N0 is the same thing. This is your starting point. And then both of these here have this plus and minus symbol, meaning that if it's plus, like if you're gaining value, so plus is for the gain value, because you start at 100% and then keep, let's say, 20% of your value every year, you earn 20%. You have to keep that whole 100%, which is the 1, and then also you like add the 20% onto it. The minus is when you lose value or the decay, like we talked about. It was 1 minus 0.2. We kept 80% of our value every year, which was 0.8. It's also important to note that rates always in decimal instead of percent. So if I said 75% in your calculator, you could put 75 over 100, which would be 0.75. So you always need to be writing your rates as decimals. So this is kind of like all the pieces of the puzzle. For those exponential growth and decay problems, this should be review, as I said earlier. So kind of jumping right into one of those problems, it says how much money in a money market with an annual interest rate compounded daily, monthly, and yearly. So when you see this word compounded, you know that you need to use the compound interest formula. And the compound interest formula is A, you can call A like answer, 1 plus r over n to the nt, where n is kind of like this new thing, the number of times your interest is compounded. Okay, and compounded means like they pay you and then they pay you and then they pay you, so they're paying you differently. So like daily, n would be 365. Monthly, they pay you 12 times a year. Yearly, n is 1. So you're going to invest $2,000 for 7 years. So let's break down all the pieces here. This is your rate. And if you took 5 divided by 100, your decimal would be 0.05. You're going to invest $2,000. This is P, or your principal. 7 years is T, your time. So I think we have everything. We have P, we have R, we have N, and we have T. The N is going to be different for all of these. So what I want you to do is pause this video, see if you can get the answers that I get. See if you can calculate how much money you would earn in a money market with an annual interest rate of 0.5% compounded differently, daily, monthly, and yearly. So you should be trying to get 3 answers for me. So hit pause. I'm going to do my work and then you resume and show me, or, check your answers against mine. So I'm not really talking here because I am really busy writing out my answers. So let me see what I get here for the first one. The important part here is going to be order of operations. So for the first one, daily, and I'm out of room, daily I got 283,807. Remember, we're talking money, so go to 2 decimal places. And if you got something different and I did it wrong, you guys know that I do it wrong all the time. So it's quite the possibility that I did it wrong. I'm going to have to stop because, as you can see, I'm reaching my limit. And so I'm going to move on real quick. You have homework. I will show it on the next slide. I'm going to time out here in 10 seconds. So I'm probably not going to get my next one done to the 7th times 2,000. Oh, I missed it.